Welcome to PH 110 Sessional 2017-2018, and this is the final part of this paper, which is part 5. So far we've done part 1, part 2, 3, and 4, and we conclude with part 5. And to get started with part 5, here are the questions that we are going to look at. So the first question says, state Newton's law of universal gravitation. So that one, when you just consult your notes, it states that every particle attracts every other particle in the universe with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. So that is what Newton's law of universal gravitation says. It states that every particle attracts every other particle in the universe with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So simply for you to remember is the force, so directly proportional to the product of their masses, so we have m1 m2, but inversely proportional to the square of the distance between them. That is what Newton's law of universal gravitation states. The next question says, if the mass of the sun is this, the distance of the earth to the sun is that, and the period or revolution of the former around the latter is that, show that the universal gravitational constant, which is G, is equal to this. Okay, so to get started with this question, you recall that G, which is the universal gravitational constant, multiplied by m for the earth, multiplied by m for the sun, over the distance between them, which is squared. This should be equal to m r that squared. Now, we know that this is equal to 2 pi over t. Therefore, we're going to proceed and get this equation. So we get this equation. So while there is this, we replace it with this. Okay? So we continue and say we have G me m sun over r squared is equal to m r, and we get 4 pi squared over t squared. When we make G the subject of the formula, so G is going to be equal to this r squared multiplied by 4 pi squared divided by, remember these r's simply come on top, and we're going to remain with the t squared multiplied by the m for the sun, because the m for the earth has cancelled out each other with this one. So we remain with this equation. Now, When we remain with this equation, we simply replace with the figures that have been given in the question. So we replace with with all the figures that have been given in the question, so that we show that this is equal to that, and we remain with g is equal to, so the distance between the two we've been told is 1.5 times 10 to the power 11, which is this one. Okay, which is this one. So this one is squared multiplied by 4 pi squared, which is this part here. All this divide by, now the t is 365. We know that the period of revolution is 365.3. So t is 365.3, even it is squared. Then we're multiplying by 24, because that's 24 hours. Then we multiply by 60, again by 60. And finally, we multiply by 2 by 10 to the power 30. So when we punch this on the calculator, sorry, this shouldn't have been squared. Okay, so when we punch this on the calculator, we remain with the final answer being g is equal to 6.69 multiplied by 10 to the minus 11 Newton meter squared kg, like that. So this has actually been shown that the g is equal to that. So to get through this question again, so just remember the formula there, and then also remember that, remember where it started from, remember this formula, and where there is this, you replace and then you simplify, and finally just replace with the figures given in the question, and we get the final answer to be that. Okay, so the next question says, a satellite revolves in a circular orbit at a height of 200 kilometers from the Earth, from the surface of the Earth. If the period of revolution of the satellite is 90 minutes, and the mean radius of the Earth is that 6 by 10 to the power 6 meters, calculate the average density of the Earth. So I want to find the average density of the Earth. So what we do is, we are given this now. Let's say this one is the Earth, and we have a satellite rotating there. Now, if this is the Earth and we have a satellite rotating there, so what we do is, we know that msg is equal to, formula for the gravitational, this is the g, then we have m satellite multiplied by m Earth over r squared. Now we know that this m will cancel with this m, and what we just remain with now is g is equal to capital letter G me over r squared. So let's get the mass of the Earth there. So we make ME the subject, it will give us G multiplied by R divided by universal G. So if this is the formula, this is the formula now which we export to the next page. Remember, this is R squared. So finally, what we get now is ME being equal to GR squared over capital letter G. So just replace 9.8 multiplied by the R that we've been given is 6.02 multiplied by 10 to the power 6 squared divided by G, which is 6.67 by 10 to the minus 11, and finally we get the mass of the Earth to be 5.32 times 10 to the power 24 kg. Now, if this is the mass of the Earth, we know that density, or rho, is equal to mass over volume. And therefore, our mass is that we have the density we need to find, and the formula for the volume is actually 4/3 by R cubed. Therefore, we're just going to have 5.32 by 10 to the power 24. And we've been given the mean radius there. So when we replace 5.32 by 10 to the power 24 over 4/3 multiplied by pi multiplied by the mean radius, which the question gives us, is 6 by 10 to the power 6. So if we replace there, we're going to actually find our answer to be the average density will be 5.885 times 10 to the power 5 kg per cubic meters. This is our answer. Okay, so let's look at the next question here, which is C. It says a coin is placed at a turntable with this. If the coefficient of friction is that, how far from the center of the turntable can the coin be placed without tipping off? So to answer this question, actually, what we do is we say, we know that this is equal to, where it is given in rev per minute. Now let's convert to radians per second. So we multiply with 1 m there, minute, which is equal to 60 seconds, multiplied by 2 pi, which is in radians, divided by 1 rev, and when we punch on our calculator, that gives us a value of 3.4371 radians per second. So we have converted to radians per second. Now we know that F is equal to Fs, which is equal to mass times acceleration. We also know that Fs is equal to mu, coefficient of friction, multiplied by Fn, where we know that Fn is equal to mg. So we simply say mu s multiplied by mg is equal to mv squared over r, which is the same as m, we get r this squared over r. So the m and the m there will go, and if we make this the subject of the formula, so we are going to remain with r being equal to mu g over this, which is equal to, when we replace the mu is 0.1 multiplied by the g, which is 9.8, divide by, into radians per second, what we found was 3.4371. And finally, this gives us a distance of 0.081 meters. So this is the distance that is required. So let's look at the final question, which is on electricity. So here it states, it first says that states Coulomb's law. So Coulomb's law, you can easily check this in your notes. It says that the magnitude of electrostatic force of attraction or repulsion between two electrically charged particles is directly proportional to the product of the charge and inversely proportional to the square of the distance. So that is Coulomb's law. Number 2 says the charge in figure 7.1 are located at vertices of an equilateral triangle of 50 centimeters with Q1 that, Q2 this, Q3 this. Find the magnitude and direction of the electrostatic force on Q2. Okay, so the magnitude and direction of this Q2. So let me just reproduce this triangle, which is, we have been given it is an equilateral triangle. Therefore, it is 60 there, and also 60 there. So if we protrude this and that there, it is going to have 60 there. Now, if I do this, and this one, just as a way of showing, then now we need to find the magnitude and direction of the electrostatic force there on Q2. So we have Q3 and we have Q1. So according to Coulomb's law, we know that F12 is equal to constant Q1 Q2 divided by R squared. So this one will be equal to, right, 9.0 multiplied by 10 to the power 9, that's the constant, multiplied by the charges there, it's 5 by 10 minus 6, multiplied by 6 times 10 to the power minus 6, divide by, the distance between them is 0.5 according to the question, squared. So equally, we have the force 3.2 is equal to K Q3 Q2 over R squared. So this one again is equal to 9.0 by 10 to the power 9 multiplied by the figure that were given in the question, 6 by 10 to the power minus 6 multiplied by 0.4 multiplied by 4, by 10 by 10 to the power minus 6. All this divided by 0.5 squared. So when we count this on our calculator, we get A and B, and we know that our A will give us 1.08 newtons. Our B is equal to 0.864 newtons. Now, having been given this, we can also go ahead and calculate F32 being equal to F32 cos theta, which is equal to 0.864 cos 60, and this gives 0.432 newtons. We also go ahead and find force 32 in y. So this one was in x, so this one will give 0, so it will be F32 sine theta, which is equal to 0.864 cos 60, and when we punch on the sine 60, sorry, not cos, since this one is in the y, so if it is in the y, it will be 0.864 sine 60, and this is equal to 0.748 newtons. So we have our forces there. Then the resultant, for us to find the resultant, we say F resultant there will be equal to 1.08 plus 0.432. This one will be I minus 0.78 J. So this one, to put it in polar form, it is 1.512 I minus 0.748 J. So that is what we get, and continuing from there, we know that our F3 will be equal to the root of 1.512 squared plus minus 0.748 squared, and this gives us 1.69 newtons. Then to find the angle, we know that theta is equal to tan inverse of 1.512 over minus 0.748, and the answer that we get there is negative 63.6 degrees. So this is our answer. So the magnitude is this and the direction is this. Finally, let's look at the last question for this part, which is electricity. So it says state Kirchhoff's current and voltage rules. So Kirchhoff's current law, just consult your notes. It says that the sum of all currents into a node must equal to the sum of all the currents leaving the node. Then for the voltage law, Kirchhoff's voltage law states that the algebraic sum of the voltage across the loop must always be equal to 0. So we have this diagram, and we are told that we need to find the currents in each of the circuit. Apart from the currents, the voltage drops across these resistors. So we have our diagram, and when we have our diagram, we know that there is I1, I2, and I3. So what we do is this diagram, just reduce it there so that we can write. So this diagram, if we apply Kirchhoff's current law, we're going to have, Kirchhoff's current law, which is KCL, we know that I1 plus I2 plus I3 should be equal to 0. All these currents should be equal to 0 when we add them. Then when we apply KVL, Kirchhoff's voltage law, we know that minus I1, 8 plus 12, so the 8 ohm resistor plus the 12 ohm resistor for this one, we close brackets, plus 6 minus 3 plus 20. So plus 6 volts plus 3 there plus, so that's the 6 minus 3, then plus 20 I2, 20 I2, all this should give us 0. So when we simplify there, we get minus 20 I1 plus 20 I2 is equal to minus 3. That is our equation. We put that equation aside. Secondly, we also know that minus 20 I2 minus 8 plus I3, open brackets, 9 plus 6. So we have 9 plus 6. All this should give us 0. So when we simplify that, we get minus 20 I2 plus 15 I3 is equal to 8. So we keep this equation. Equally, we also keep that equation. We also go ahead to also replace 1 into 3. We're going to have minus 20 I2 plus 15. Then we have minus I1 minus I2 being equal to 8. If we simplify this, we get minus 20 I2 minus 15 I2 minus 15 I1 is equal to 8. Therefore, minus 15 I1 minus 30 minus 35 I2 is equal to 8. So this one will be our equation 4. And if we solve equation 2 and equation 4 simultaneously, remember the other equation that we found. So we have this equation as our equation 1, we have this one as equation 2, and we have this one as equation 3. So now we are solving equation 2 together with equation 4 simultaneously. So we get minus 20 I1 plus 20 I2 being equal to 3. We also have minus 15 I1 minus 35 I2 being equal to 8. So if we solve this simultaneously using simultaneous methods, we're going to end up with finding our I1 to be equal to 11 over 200, which is 0 point something. So let's leave it in fraction form there. And then when we have found our I1, we're going to say I3 is equal to minus I1 minus I2. That is from equation 1. So this will be equal to minus 11 over 200 minus, by the way, if we find I1 there, it also gives us I2 to be equal to minus 41 over 200. So minus 11 over that, or minus 41 over 200, which is I2, and we find that our I2, our I3 will be 3 over 20. And lastly, the question is asking us to find the voltage drop across the 9, 20 and the 12 ohm resistors. So if we have our I1 to be equal to 11 over 200, our I2 to be equal to minus 41 over 200, and our I3 being equal to 3 over 20. So to find the voltage drops, we know that V is equal to IR. So this one will be equal to minus 41 over 200 times 20. This is the current passing through the 20 ohm resistor, and this one will be minus 8.2 volts. Again, we're going to have voltage drop across the 12 ohm. We have 11 over 200 as the current passing through the 12 ohm resistor, and this one will be 121 over 200 volts. And lastly, the voltage drop that is passing through, this is IR. Now the voltage drop across the 9 ohm resistor is 3 out of 20 multiplied by 9, and the voltage drop is 27 out of 20 volts. So these are the voltage drops across each resistor. Well, this marks the end of our sessional paper. I hope that you followed, and if you have any questions, please feel free to reach out and we'll be able to assist you. We wish you all the very best.